Hello everyone, my name is Fatma Ali Abdel Nabi and I am here with my team members Hussein Osama Abdel Abbas, Zainab Bashar Yarub, Muntadhar Basim Mehdi, Benin Saad Amr, Malak Murtada Hassan, and together we'll be presenting about turbines, one of the most important inventions in the engineering history. Every time we use electricity, fly on an airplane, or turn on a tap, there's a turbine working silently behind the scenes. And this presentation will cover what a turbine is, why it matters, and how it works. I hope you find it informative and interesting. Let's get started. A turbine is a rotary mechanical device that extracts energy from a fluid flow and converts it into useful work. It operates on the principle of transferring kinetic or thermal energy from a moving fluid, such as steam, gas, or water, into rational motion. Turbines are a core component in power generation systems worldwide. Next, I'm going to talk about the purpose of turbines. Turbines are the backbone of electricity generation in power plants worldwide. In fact, over 80% of the world's electricity comes from turbine, and it's used in gas, steam, hydro, and wind energy systems. They are used across all major energy types, whether it's burning fuel, flowing water, or blowing wind. Turbines can convert all of these into electricity. So it's very important in electricity, as we just said. And it's essential in aviation. Jet engines rely entirely on turbine technology. In innovation, jet engines are basically gas turbines. Without turbine technology, modern flights simply wouldn't exist. Also applied in marine vessels or refineries and industrial manufacturing. Bewind power plant turbines power ships, drives oil refineries, and run heavy industrial machinery. Highly efficient at converting thermal and kinetic energy into mechanical work. What makes turbines special is their efficiency. They can convert up to 90% of energy input into useful mechanical work, which is remarkable compared to other machines. Play a central role in the global shift toward clean and sustainable energy. And today, turbines are the heart of the clean energy revolution. Every wind turbine you see is a proof of that. Let's take a look at the anatomy of a gas turbine. First is the compressor section. This is where the journey begins. Air is pulled in from outside and squeezed to very high pressure, then sent to the combustion chamber. Combustor. Here the compressed air meets fuel and burns continuously, creating extremely hot, fast-moving gases. Third thing is turbine section. The hot gases hit the turbine blades and spin them. This spinning motion is how we get mechanical energy out of the system. And then is connecting shaft or rotor. This shaft is the link between everything. It carries the spinning power from the turbine back to the compressor and also drives the generator to produce electricity. Now let's take a look at the combustion chamber. First thing that I'm going to talk about is core mechanism. Here compressed air mixes with the fuel and burns continuously, releasing hot, high-pressure gases toward the turbine. And then we're going to talk about thermodynamic state. The pressure stays constant while temperature rises sharply. This is the Brayton cycle's heat addition stage. Airflow distribution. Only 25 to 30% of air is used for burning. The rest cools the chamber walls and controls the gas temperature. Material engineering. The chamber reaches over 1,500 Celsius, so it's built from nickel-based pearls with special cooling systems to handle the heat. I'd like to take a closer look at this point, which is how the turbine actually works. How it works. Hot gases from the combustion chamber enter the turbine at very high speed. These gases push against the turbine blades and make them spin. The spin in motion generates mechanical power. This power is used to drive a generator or propel an aircraft. Key facts: the blades are made from special heat resistant materials. The turbine spins at very high speeds, thousands of times per minute. Part of the power is used to drive the compressor. Working principle: the gas turbine works in 4 steps called the Brayton cycle. First step is intake. Air enters the compressor from the surroundings. Second step is compression. The compressor increases the pressure of the air. Third thing is the combustion. Fuel is mixed with compressed air and ignited. This produces very hot, high in energy gases. And fourth thing is expansion. The hot gases expand through the turbine. They push the blades and generate power. The exhaust gases exit the system. Now let's talk about the control systems. Control systems are essential components in turbine operation, ensuring stability, safety, and efficiency. They continuously monitor and adjust turbine performance under varying conditions. These systems regulate parameters such as speed, temperature, pressure, and output power. Modern turbines rely on automated control systems to optimize performance, reduce human error, and maintain consistent operation even under fluctuating loads. This drives us to how control works. Turbine control systems use a feedback loop. Sensors constantly measure the temperature, pressure, and speed, then send this data to a controller. The controller compares the actual performance with the desired set point, and if something is off, it sends signals to actuators to adjust the fuel flow, steam, or blade position. This loop runs continuously to keep the turbine efficient, safe, and stable. Let's take a look at the control system types. First control system I'm going to talk about is speed control. This keeps the turbine spinning at a constant speed even when the load changes. The second system I'm going to talk about is temperature control. This monitors heat levels to prevent overheating and to protect the turbine parts. Another important system is pressure control. This regulates fluid flow inside the system to keep everything running smoothly. Moving to number 4, which is load control. This adjusts how much power the turbine produces based on how much is needed. Moving to number 5, which is safety shutdown. Safety shutdown: if anything goes wrong, the system automatically shuts the turbine down to prevent damage. Last system I'm going to talk about, which is digital control. Modern turbines use computers to monitor and automate everything with high precision. Applications of gas turbine. We can find gas turbine everywhere in the planes we fly in the power plants that gives us electricity, in oil pipelines, and even in ships crossing the ocean. And this slide will cover 4 main applications: power plants, aircraft engines, oil and gas industry, and marine systems. First application I'm going to talk about is power plants. Gas turbines are used to generate electricity. They burn fuel to spin a generator, powering homes and cities. Second application I'm going to talk about is aircraft engines. Jet engines are basically gas turbines. They produce the thrust needed to lift and move the aircraft at high speed. And moving to number 3 is oil and gas industry. Gas turbine power pumps and compressors that move oil and gas through pipelines over long distances. Last application I'm going to talk about is marine systems. Large ships and naval vessels use gas turbines for propulsion because they are powerful, compact, and fast to start. Let's see how the turbine relates to the mechatronics. So a gas turbine is actually a perfect example of mechatronics because it combines all the 3 fields together. First field, which is mechanical engineering, the muscle. The physical parts like the compressor, combustion chamber, and the blades, these must handle extreme heat and high-speed rotation. Now, this wouldn't work alone without sensing what's happening inside, and that's where electronics comes in. Sensors measure temperatures, pressure, and speed, then convert them into electrical signals, just like how our sense send signals into our brain. But collecting data isn't enough. Something needs to process it and makes decisions. Programming and control. The control systems receives all that data and makes decisions automatically, adjusting fuel flow, optimizing performance, and shutting down instantly if something goes wrong. So as we can say, the turbine doesn't just run mechanically, it thinks, senses, and reacts. That's exactly what mechatronics is about. The conclusion. To wrap things up, a gas turbine is not just a simple machine. It's a powerful system that combines mechanical design, thermodynamic processes, smart control systems, and advanced materials, all working together. From generating electricity in power plants to flying aircraft across the sky to powering ships in the ocean, gas turbines are truly everywhere in our modern world. As mechatronics engineers, what makes this topic special to us is that a gas turbine represents exactly what our field is about: machine, electronics, and programming working as one. Thank you for your attention. I'm happy to answer your questions.